So this is the recording for the cloud platform for the Blockswap. We're gonna talk about a bunch of things related to what is a cloud, what it does, how the restaking actually works, who is qualified for restaking and how they can actually do that, how the slashing works with the slashing collaterals, and how can you slash a validator who has a deposit in the consensus layer that has been locked and that is not available in the execution layer. So all the contracts are on the execution layer. So you're basically dealing with a different chain assets and different chain security, but you're having a contract in between a chain consensus layer, and then you have execution layer. But you are allowing other middlewares, let it be from Ethereum, let it be from, from other blockchain environment, can source the security of Ethereum consensus layer. And at the same time, the validators offer slashable ETH for others when something goes wrong. So there are two things. It limited only to active Ethereum validators. So that's what the marketplace. And then it matches a lot of middlewares have their own custom requirement, and they want to decentralize. They want to hire node runners. The better path is go to the best quality node runners out there, but with some sort of slashable security if they are just going off. So if you look at this decentralized way, the best security, decentralized security in the proof of stake is available on Ethereum. It's 200 billion at a scale, but now we have about 20% stake and may get about 50% as an average. But what we get here is a security is unmatched with any other networks, can be reused. What that means is security can be reused is a machine that is protecting on average of $12 billion per day transaction settlement for execution layer. Everyone's about 600,000 validators out there. You can hire, and that will be like 1.8 million or something like that. And if a lot of people actually come in, you can have all these machines available for you and a smart contract will coordinate. You just say, go and say that as a middleware, hey, I want to hire you guys, but I also want to rate you, just like how you choose an Uber or an Airbnb, like you want a 5-star or 4-star, 3-star. You can basically get that efficiency of a validator from on-chain balance. And the contract will give you that. So you say that I want to have 28 from 32, the base threshold. And then that's the validators can opt into you to run your service, and they will run a service and they will collect the money from the cloud smart contract. So everything is automated. So there's a lot of coordination going on. A execution layer contract knows about the consensus layer chain state of a particular validator, and it readjusts the balances on a weekly basis. That's another cool thing here is like the payout management is automated. So the payouts to the whole validators are on a weekly basis, it get automated. But when you come to the pool, if someone is not working, then that should get redistributed to other people. That's also getting managed. But then some of the middleware says that we'll pay you a standard fee, but we also want to pay some other things, right? Incentives for particular kind of a class of validators or particular kind of node validators. We want to have highly diverse node operators. And we found this would be better if you go for a DVT class, and we identify all the BLS keys associated with it, and we want to give additional, incentives for them. Or we want to have solo stakers because that's the most. So this way, you're basically getting this kind of infrastructure, decentralized infrastructure of Ethereum created with a lot of security budget. It's readily available for you to have it. You get this kind of highly decentralized thing without even taking any effort other than just listing your incentive for a contract. So you can just develop your innovative ideas on the application level without worrying about how do you congregate all this kind of validators? Where do I go? What is incentive? How do I talk to the node operators? Everyone is already here. At the same time, the node operators get this kind of high quality services that who require decentralized, but they get proper accounting on the assurance, the money they should receive will come to on a weekly basis. But then the other part is slashable ETH security going to them. So they say if we don't do something in their network, and then we're going to get slashed on the ETH that we have on Ethereum. That's the cool thing, right? So you get also the slashable security, but that slashable security will have a custom logic. So the middlewares need to tell them what is a slashable events that could be like, few things they want to inject and that they can superimpose on the logic, and that will be reported via theoretical reporter. So there are a few things like a zero knowledge scheme was a reporting mechanism that allow you can inject unknown, unverified data, untrustable data to a verified manner to the contract, and the contract will immediately slash it. So there is no oracle, there is no, in between people just making kind of arbitrary decision. Everything is automated, everything is contract, and then we are taking cryptographic guarantees. So it's a very immutable contract. It just run its on. Yeah, I mean, bunch of words here. Let's get to the details. Vincent, do you want to give a high level overview of like just to show a visual hook before we getting into the technical stuff? Who's a reporter? Who's a payout pool? What is SLA? What is the mini SLA?
Yeah,
How does it work?
yeah, definitely. Yeah, so we can unpack this one by one and sort of get a better like sort of understanding on what's happening here. But the key here is that we're using a smart contract based coordination, and we don't have to worry about like you said. So service providers don't have to worry about where they're going to find the validators for executing their software. So the cool thing here is that you will know that through a derived consensus layer mechanism, so you'll know whether the machine is online and performing duties, and you.
You muted.
Oh, was I mute the whole time?
No. Just for 10 seconds. It's fine.
Oh, right. Okay. No problem. Okay, cool. So what we can do is actually we can do some kind of like okay, so we can do some kind of whiteboarding. Maybe that will sort of help sort of frame things in a way that maybe is so it's how do we use the smart contract based architecture to perform the relevant coordination needed to connect sort of service providers who have wants a service to be executed on a machine. So you have like an entity or an individual that has so you have the service provider. And they have some software to run. Now we have on the other side we have node runners, and they are set on the other side with so node. We have a node here. We have nodes, and the thing about these so by default, the to participate in Blockswap Cloud, you are going to be an active Ethereum validator. So this active Ethereum validation is going to make you eligible for participating via the cloud, right? So the cloud here, a cloud here is in the middle, connecting the
So
basically connecting the node operators with service providers.
what is a cloud? Is that like what is it? What does it refer to? It's a
suite.
contract.
It's a suite of smart contracts. Yeah,
okay.
it's a suite of smart contracts. So these, so cloud is just the term for all of the infrastructure inside of the cloud ecosystem. So we have so let's say we have this cloud ecosystem. And the thing is here that, so yeah, this is just Blockswap Cloud. So what we have is, so we have these node operators here on the right that have these machines. They're running Ethereum validators at a fixed cost, right? So they have, whether it's hosted on AWS or like they're a solo staker running their machines at home for the best kind of decentralization of the Ethereum network. They are already running those machines. So um, often because the Ethereum consensus layer to execution layer, the software used to run that is fairly lightweight. Some people are running them even on Raspberry Pi devices. So you basically have like machines with spare capacity that can offer services to additional node runners. But you want to be able to use the cloud to coordinate these two entities, but also to take care of malicious node running and all that sort of stuff. But we have smart contract based coordination here. So we have like a suite of smart contracts. So we have it at the core. We have like a payout pool. So a payout pool is there for service providers to pay for the services that they have like engaged. And on the we also have we have on-chain proposer registration. So we have on-chain like we'll call it just validator registration. And we have like figured out all of the BLS registration mechanisms. So for these node operators that'll be running, they could be running any number of BLS keys on these nodes. They will register inside of the proposer registry in order to be eligible to participate in this offering their nodes for service providers. And service providers basically they are registering SLAs. So they create these SLAs and they will specify sort of, via the middleware, they'll specify the service that they want, the software that they want the node runners to be running, for how long,
what is SLAs?
It's just like basically a definition of a service that needs to be run, and it will define the agreements.
So it's a stake lease agreement.
Yeah. It will define like sort of duration.
But this is predefined, right? So SLAs, there's the common template, just like a pool, but just you basically deploy an SLA and you just select what you want to do, what you want to get it from the validators, and in return, how these slashing conditions also go.
Yeah. So So you'll define like a set of like penalties, penalty definition, and that will lead to slashing. So you have you'll define like duration of the expectations of the service. You will define the reward tokens, amounts. So basically, when you are creating an SLA as a service provider, you are basically defining these parameters. And so when a node operator with their validators decides to restake their validator and offer the spare capacity of their nodes to service providers, they can look up all the different SLAs on, you can think of it like a sort of there's an SLA sort of factory. You can think of it SLA factory, sort of job board. And it'll have many of these SLAs. People can basically say, yeah, I want to participate. I want to be part of that, service, that service agreement. because I want to earn funds from the payout pool. So this is all connected because the nodes are going to be registering their BLS keys they're going to be registering the BLS keys to the payout pool via this validator registration module. So they'll be registered here. And when they join SLAs, they will be eligible for payments from the payout pool. So the SLA here, second, right. So the SLAs will drip funds to the payout pool. So, but so long as the validators are performing their duties, if an SLA said, okay, well, we're going to pay 1,000 USDC for 1 week to all of the validators that join the SLA, then they will get that funds so long as they're online. You can see that from the consensus layer. Their earnings will be derived from the inflation rewards accrued on the consensus layer. So we derive the ability to earn a pro rata share of the SLA from your performance of from the consensus layer. So you really are deriving your security from Ethereum because we are reusing the consensus rules for monitoring the validators in order to distribute payments. But if there is any issues, if there is any amount of money that these validators are earning that needs to get slashed according to the SLA slashing rules, then the payout pool can self-adjust. So it can say, well, one guy didn't do didn't run the software, or submitted an invalid result, and so their earnings need to be adjusted and distributed to other people and reporters. So what we have here is these additional entities. We have reporter entities. So the reporters are the reporters sort of a key. They're a key part of the system and created within the Blockswap Cloud stack. So reporters are a very familiar concept if you are you're aware of the Blockswap infrastructure and stack. You'll be aware of the concept of the reporter that will they will be on the basis of the rules defined by the service providers and the performance of the nodes. They can report issues to the payout pool and say and prove that cryptographically that perhaps a validator violated some of the rules of the SLA, shouldn't earn as much, and so the pool can adjust the earnings accordingly.
Right. So just want to ask a question. So the reporters, because the name is very interesting, is this something to be a manual process, or how does it work? Like user will report. Is it a software that I just switch it on and then it will do the job as it on? Or is it something that I need to come back? Oh, there is some sort of an issue, an event triggered. Let me report this or something like that.
Well, it can be, it can be automated in any way you want. It is just a standalone software that it's kind of it can be designed to be plug and play, so that you can just if you want to register as a reporter. So reporters need to be registered in a reporter registry, and they need to put up some collateral to protect against any malicious sort of behavior. But that aside, it is going to be just a software that can be run that will look up via the SLA middleware. It will look up it will look up sort of any violations that have taken place by node operators. So basically, the penalties are going to be well defined. The boundaries of that are very well defined. So it is possible to have like an automated software. You just download it on your machine. You register as a reporter in a smart contract, and once you're registered, then you're able to you're able to search for penalties. It's just like you could just think of it as a bot that is running on your machine, searching for penalties and reporting issues. You don't have to be a service provider to run a report. You don't have to be a validator running a node. Anyone can sort of join the reporter network and look out like a watchtower and highlight any violations. So it's completely sort of permissionless in that respect.
So what good thing is like I'm seeing here is like it just simply an open marketplace for you can source Ethereum security with a slashable deposit, but the middlewares can experiment not only for the mainnet, even way before they want to go from like any kind of, they can take a stage by stage process, right? Even though the decentralized, just come here first and say that, hey, we want to run it only for 2 months and let's see how this works. And yeah, I'll pay for it, and they'll opt in, and then you do it. Once that is duration is finished, all good. It's everything is wrapped up, and then they can come for a second time, third time. So it's very easy. Like they can iterate much faster. The decentralization go.
Yeah, absolutely. And they don't have to worry about where are they going to source the machines, the validators, the node runners to actually to execute their goals. They just have to put up putting up a job on a job board and just say we're looking for Ethereum validators. So the SLA needs to define sort of the minimum effective balance of the validator. And so that is just defining the quality of the validators that you're hiring.
What kind of validators that you want to, run your network, right?
Yeah,
exactly.
exactly.
Do I need a limousine? Do I need a small car? You want a big van? Depends on what you want, right?
Right. Not every service, not every piece of software will require a validator with 32 effective balance.
Yeah.
But some may. Some may say we only require the best quality validators.
Yeah. Cool. So how does a validator can register to this?
So validators initially they are making sure that they are registered in the validator registry. Or it's also known as the proposer registry. Basically, they need to present their BLS public key and prove that they're in the signing key cryptographically. And then they can join the validator registry. But there is an activation distance involved here. So inside of this, so this distance allows the validators to configure their software, sync the chain. So the cycle distance is 7 days. And once they are activated, then in the validator registry, then they can join various SLAs. So the validators will actually present themselves to payout pool and say, hey, I'm registered, I'm activated, I'd like to join, a specific SLA. So each SLA will deployed by the SLA factory will have a unique identifier, and the validators will say, I would like to join that SLA. I am happy to run the software for that duration because and I would like to get the pro rata payment for doing that. That obviously, so they just from a validator perspective, it's just download software, earn money. From an SLA perspective, it's put up a job, put up some tokens, and pay some validators for doing a job. But the thing is that
I know we're getting into the details slowly, but just want to touch one thing, like the validator when they register. Where does this slashable security comes from? How can you get each slashable? Like, so does this validators have to put up some collateral to slash, or because it's the ETH is sitting on consensus layer, right? And you have an SLA just for 2 months, and then you cannot slash on consensus layer. It doesn't really have any kind of smart contracts. This is all happening on execution layer. It's a different blockchain. I mean, it's a different state. It's a different state DB. I would put it that way.
Right. So, So the stake for the validator is on the Ethereum consensus layer. And so the Ethereum consensus layer, let's say, wait a second. Yeah. So this validators, they are registered on the Ethereum consensus layer. So these validators here. So let's say this is Ethereum consensus layer. So so Ethereum consensus layer will register these validators, and they will have Ethereum has this like validator list, and you'll have validator of X123, and it has active balance here of 32 ETH, and that money is this money is locked on the consensus layer, and in the possession of the node runner. So Blockswap Cloud does not, require any access to the withdrawal credentials of the validator that is registered on the Ethereum consensus layer. But what it does require is putting up an ETH collateral. So when the user is when the user basically registers here in the validator registry, so they put up a collateral. So there's a collateral vault, and they will deposit ETH security into the vault. And it's simply ETH. So they will deposit funds into the collateral vault that can actually compensate reporters. It will compensate reporters, and it will compensate service providers in the event that the slashing, the slashable offense takes place.
This is an additional money that is required for validators. Is it? If everyone has to bring money to that? Like, how does it work?
You need to supply tokens to the collateral.
You need to supply what about the Stakehouse validators?
Collateral. So Stakehouse validators are a special. Stakehouse validators already put up collateral at stake. So when in the Stakehouse protocol, let's say these validators joining Blockswap Cloud are Stakehouse validators. So we have the Stakehouse protocol. So the Stakehouse protocol. We have the Stakehouse protocol. Every validator puts up. It's owned by the node operator, but every validator puts up collateralized slot. The collateralized slot is a token that is the node operator puts this collateral up for slashing in the event that they are performing malicious operations on the consensus layer. For example, if there is a slashing event, so a double signing, maybe it can be by accident or like an intentional attack on the network. So you have a collateralized slot token. You have other tokens in the protocol. You have but that we'll just ignore them for now, right? So, but this collateralized slot is a token that is in protocol slashable token for malicious operations. So in that event, so if a Stakehouse protocol validator wants to join the cloud, they can do so, but they do not have to provide ETH collateral for slashing. They basically, let's say one of these keys was actually a Stakehouse validator. They would approve. You would hear this. You would approve slot for slashing by cloud. So the collateralized slot is 4 tokens, right? So if you go on docs.joinstakehouse.com, you can find more information about the tokenomics, the model of how the debt position of a validator is being minted, and 4 ETH from the 32 ETH deposit that is sent to the Ethereum deposit contract is minted in protocol in the vault, in the collateralized slot vault of the slot registry, and it's slashable for serious offenses. And when you join the Blockswap Cloud, you are required as a Stakehouse validator to approve this. So you already have collateral at stake for a validator, a Stakehouse protocol validator. You don't have to provide additional collateral when registering with the Blockswap Cloud. But if you're a validator, so Blockswap Cloud will accept any validator from any validator on the Ethereum consensus layer. It doesn't have to be specific to any protocol. And if you're a non-Stakehouse validator, you need to put up ETH collateral. That can be slashed according to the rules defined by the SLA provider, but you don't have to give up your withdrawal credentials in order to do that, to put up the additional collateral. But that collateral is withdrawable at any time. So the Blockswap Cloud, just like any other Blockswap protocol, it will allow permissionless entry and exit. So if you no longer want to be part of the cloud, you can rage quit and you can basically claim your collateral back. So
Stakehouse protocol validators doesn't really need to put any more collateral, right?
Yeah, that's correct. That's correct.
Zero. So yeah. Others need like 4 ETH or something.
Yes. Yeah. They will just put up 4 ETH.
Okay, cool. Right, cool. Thank you. I just want to understand that. And you can top up when it gets slashed. So it's just immediate. Slashing is immediate, right?
Right. Exactly. So, but until you top up, it will affect your earnings. So you're incentivized just to top up the contract and to continue your operations. Otherwise, you just get demoted and you won't be able to continue to accrue earnings from the payout pool.
Do we want to get into nitty-gritty, like get Andrea into the room and just go through the states? How does the registration? How does actually that all these things actually works?
Yeah. So just before we jump into that, one thing I just remembered is this incentivized SLA pool.
Oh yeah, this is nice. Yeah. Oh, so that brings me like a lending pool actually can provide that 4 ETH collateral for the validators. No problem.
In order to register with the cloud.
Yeah. And then they can. I think that actually it's no problem with that. So you can actually lend the 4 ETH, and the node runners doesn't really have to worry about it, but then they will share some of the yield between the lending and the restaking.
Okay. So you have an additional guy basically like registering your validator on behalf of you. They're putting up the collateral, and in exchange for putting up the collateral, they will take a cut of the earnings and give you the whatever you agree, right? So they'll give you the leftovers.
Yeah. It's basically increase your ETH yield. That's it.
So basically, it's like in that case, it's kind of like you have like an in-between guy. So you have like
any lending protocol, like I have a compound or even just a simple vault, like you can just spin up a lending, say, hey, deposit all the ETH here. It will be consumed by the validators, and you'll get a pro rata. The pool will get a pro rata yield from all the validators just consume as a collateral. Great. Like a strategy or lending strategy. Like if you don't have 4 ETH, don't worry. Just take it from me and just share the money that you're making.
Right. So if I'm a non-Stakehouse validator, you're saying that I can okay. You're saying if I'm a non-Stakehouse validator, that means like I have a collateral requirement when I register. So if I go direct to do the validator registration, I need to put up ETH collateral. I need to put up 4 ETH. But if I don't have the 4 ETH to register with the Blockswap Cloud, I can go I can go via a lending protocol. They will register the validators for me in the validator registry, and they'll take a cut of the earnings, right? But give me the rest.
The pool will get the standard cut from all the validators who borrowed from it. It's not very, very big deal. But the thing it is, in Stakehouse, if it is a ZEC, your collateralized slots were basically being, borrowed from a pool, from a 0 8 club pool, you know? So, but that's at the
Mm-hmm.
LSC network level. So not necessarily that node operator has that money, but it will go, a portion
Okay.
will automatically goes there. But here it is like you can just put all the ETH and
Mm-hmm.
then, oh, that can be borrowed, and then you pay a haircut to them, and then you will get it from there.
Right.
But that could be that's
That's
totally possible. Yeah.
that's
So
definitely doable. Yeah.
yeah,
The Blockswap Cloud doesn't care where the money comes from, right? It's just all
yeah,
smart
doesn't.
contracts. It's
Yeah,
just,
yeah,
the
yeah,
rules for registration are just you need to
yeah.
have you need to be
Money.
active on the consensus layer,
Yeah,
bring the
yeah,
money, and
yeah,
then you've got access to all of the you've got access to the SLAs, and inside of the SLAs they're defining their entry requirements. Some of them might not just define an effective balance requirement. Some of them may actually define and say, look, I want to do some restaking. I have a software for people to run, and I need only 1,000 validators, or I need 200 validators. So an SLA may have a capacity requirement. Once that the capacity is full, it's full, right? But what they also may do is they may also incentivize their best performing validators. So, say for example, you have imagine you're a node runner, and in this node, it's got two BLS keys registered. So this BLS key registers to SLA1. This one is also registering to SLA1. So we have three keys actually registered here. Now, the SLA provider says, okay, well, okay, so there's these people, they're earning some coin, and let's imagine one of the BLS keys outperforming all the rest of them, or like basically put it another way, a subset of all of the BLS keys are really special, and the SLA provider says, okay, what we'll do is we're going to spin off a mini SLA pool from the original one. And it's going to have a subset of the keys that were originally registered in this SLA in the new one, and nobody can directly join that sub SLA pool. The SLA provider automatically adds the keys that it wants to be part of that, and they can incentivize with other tokens. So they can say, well, this special pool, because they are doing, they're in the 99 percentile of the performance, and so they are going to earn some additional tokens, maybe you can imagine the bribe wars. Imagine you're earning curve like in SLA1, and maybe you're earning V curve in SLA2. Just an example, right? Because it's a familiar hook for people. So this like I said, this spinoff SLA is it's just an additional pool within that payout pool, and you can only as a service provider add the BLS keys that were in the original one, and that will create extra incentives inside of an SLA pool. So it can create some really, really interesting dynamics. We have this concept of a pool authorizer. So basically, when somebody, so let's say you're registered in the validator registry. Now you've got access to potentially join SLAs. When you try and join an SLA, that will trigger an SLA's pool authorizer contract, and the pool authorizer contract checks whether a user BLS key is eligible for joining the SLA, and it can have simple requirements. So that can be either a capacity, maximum number of validators that can register. It can be, like I said, effective balance requirements. There can be other criteria. But if the pool authorizer says they can join, they'll join that pool. But the pool authorizer, if there's any spin-off ones from that, will not allow direct joining, but it will allow the service provider to create special incentives, special pools for the best performing validators, or it could be for any other reason. But yeah, that's just there for illustrative purposes. But so this is very powerful, sort of modular building blocks for Ethereum validators to restake and reuse their hardware for more than just Ethereum consensus validation. But it all stems from the fact that they are active Ethereum validators of a certain criteria and can be used. So it allows for it. So validators. Blockswap Cloud is a very much like it's basically a very much aligned with the proof of neutrality. And so validators can have at the base Ethereum level, the consensus level, they can have predictable income every 7 days, but they can also create additional sources of income from the service provider market. So not only at the Ethereum level is the fear of loss of payment completely removed because you're getting paid every 7 days, but you're able to actually generate additional revenue streams with the same fixed cost base. So, from a validator standpoint, this is really exciting. And then you combine it with, like what Matt said, you combine it with the Zero ETH Club, the ZEC, that's coming to the LSD application on top of the Stakehouse protocol. And what you have is you have people who have machines, have an internet connection, but don't have the financial access to, 4 ETH or 32 ETH or any of those requirements that are there at the Ethereum deposit contract level to set up a validator. They can just say, hey, I'm a good guy. I work hard, right? I've got a machine ready to go to help decentralize the Ethereum network. Where do I start, right? And through various protocols, we can allow them to earn additional revenue. We'll just earn in the first place. It's kind of like, it's almost like very definition of like financial inclusion. So before I get carried away, I think it's a really interesting thing for the space. I think it would be nice to look at things from a formal perspective. So Andreas is our formal engineer inside of Blockswap, and will illustrate sort of the formal processes that we follow to ensure that we get some confidence that the system is hopefully working as expected. So.
Yep, thank you, Vince. Let me share my screen so you can see my specification of the cloud payout pool. Just before I go into this document, I want to just explain what is the purpose of this document. And it has to do with specifying exactly the semantics we want from the cloud payout pool smart contracts. And so it specify what are the properties of the different functions in the contracts, and what are the invariants that those functions need to respect. And this serves as a specification that can be used for testing, and it can also be used for formal verification later on. So in the beginning here, I just start out with some preliminary definitions, which I'm not going to go into detail with the document, so we don't need to go through this. And afterwards, what I do is that I have defined the state of the different components in the system. So we have some state of the service provider. The document is not quite finished yet. So this is the service provider has not been the state of this has not been fully defined yet. We also have the proposer and the service layer agreement, which has so for example in what I have at the moment here is that I have what is the accepted token of the service layer agreement, and what is the start of the agreement and the end of the agreement, and also what is the service provider in this agreement. Then there's some other stuff, the proposed depth, and also some of the fields of the proposal are defined in the state, and similarly for the reporter.
So wait a minute. So you say the tokens that is accepted as a collateral is either the slot or the KE.
Yeah, at the moment that's how it is. I think I'm going to change this to it could be any it can be any token.
Yeah, cool.
So it doesn't have to be this. So there was this is just a work in progress document still. Also, also so other stuff that I'm missing is the pool that the SLA pool. So at the moment there's just one SLA pool in the document. We also need to add to the document the possibility for having multiple pools.
Yeah, okay.
But that will come. Yeah, and thank you for the question, Matt. Yeah, so let's move on to the payout pool. So the payout pool has some some of the things we have discussed. That it has this reporter registry, which contains all the reporters that have been registered, and also similarly a proposer registry that has all the proposals that have been registered, and a bunch of other stuff. So yes, so let me go down and find some of the. Let me go a little more down in the document to see if I can find the proposer registry. So here, the proposer registry is supposed to is a smart contract. It will be a smart contract in the code, and so what I start out with is I state all the invariants here. So all the functions in the smart contract need to respect all of these invariants that I'm describing here. So what it means is that if this equation holds before the function is called, then it also needs to hold after the function has been called. And this is referring to the state of the smart contract. So the first thing that a proposer will do is that he will register. He will use the register operation to do that. This is actually the PR pool is a very good a way of thinking about a way of thinking about this is that it's a state transition system. So first, the proposer, what he does is he goes into the from the unregistered state into the registered state, and he does that with the register proposer operation. And then after he has been registered, he will be activated at a later point. I think Vince mentioned this, that this will be after 7 days, currently as it is. So that is after 7 days, he will be able to earn rewards. Once he has been, so this activation happens automatically. So there's no operations to do that. Once he has been activated, he can position himself for a rage quit, and after a while, he will be able to actually also perform the rage quit operation, and that is transitioning from exit pending status. So when he is preparing for the exit, he goes to exit pending, and then when he actually rage quits, he will go to the exit state. And also a proposer can top up. So if he has been slashed, he can use the top up operation to put back his stake. There's also an operation that is able to, if a proposer misbehaves in certain ways, if he is slashed too often, then he will be kicked at some point, and that is the reporter registry that is responsible for kicking the proposers if they are misbehaving too much. So yeah, the reporter registry is similar as a state transition system. You can register the reporter to get him into the registered state, and he can rage quit, and he can receive an end of cycle report. So the end of cycle report is being used to at each cycle there is a amount of tokens that can be earned, and that is the end of cycle report is being used to report how many tokens can be earned by the proposers. There's also the submit report, which is used to submit a misbehavior of a proposer.
So like, does that mean, so like, let's say I'm a service provider, I'm putting up like 20,000 USDC for like, 14 days. But if like, let's say for whatever reason, the proposers are only online 80% of the time, so then I suppose the maximum they can accrue is the 80% of that 20K, right? The service provider should get a refund, right?
Yes. So that is being handled in the. So the end of cycle report is reporting, as it is right now in the document. It is reporting what is the current rewards of all the proposals together. So the particular proposer is also. Let me go to the end of report, the end of cycle report. I think it's in the state somewhere.
So what are we reporting? Are we reporting the like consensus layer performance? Maybe, I don't know, Subhashish, like you can give some context here. I don't know.
So what I have in the document at the moment, I think that this also needs to be to be changed. So this is this is a subject to change, I think. But what it contains at the moment is that it contains the proposer rewards. So this is the total amount of rewards that have been earned by the proposers combined. This is let's just say that this is the total amount that has been earned by the proposers combined divided by the number of proposers. This is the so what the proposer drip is that the maximum amount of this is the maximum amount that you can earn in this particular payout cycle. So this is how much can a proposer earn in this payout cycle? That is the drip that is coming from the SLA, from the service provider. And then what you can do is that you can claim your rewards as a proposer payout, and you can claim for a particular cycle. And so if we go into the details of this, it gets the end of cycle report from the next payout cycle that the proposer can claim rewards for, and he gets the maximum amount that he can earn. So this is the proposer drip. How much rewards can he earn for this payout cycle? Then I'm calculating how much of the actual reward is he entitled to, and that is coming from that is coming as input. How much has he actually earned in this payout cycle, and using this, how much has he earned compared to the proposer drip? I can calculate how much is he entitled to using this equation here. So that is how it's done currently in the document. So what I mean here is that taking the amount he has earned and dividing it by the total the maximum possible amount that can be earned, and based on that we're using that to define how much of the total is he allowed to claim the proposer. But I think it's slightly different currently in the code. But maybe we can go over that. That's we will need to align this with the code, of course, so that we have exactly. So this exactly specifies how the code is supposed to work, and we can actually use this to define our tests and for the formal verification as well, if we get to that point. But it is work in progress, so I'm sure we will get it done. Any other questions?
How does this report is the claim parts, right? The claim parts is the first. The claim will settle on a cycle by cycle basis, right? So it will never get rolled over like the last cycle. It gets rolled over as in part of the total accrued deferred payments and things like that. But you will never you'll never have any trouble of getting settling a last cycle related payouts in the next cycle. So was reset in terms of what is a payoffs. Yes. So even if you want to leave, so if you're there but you haven't claimed, whenever you want to claim it, it won't get diluted by the later cycles. That's more important. Your money will be there as a validator who's serving it.
Right.
The
money will be there, but at the moment you need to be active in order to be able to claim any rewards. I mean, this is certainly that could be changed to any other state that want.
You need to be active on the registry, so you should not exit from the registry.
Yeah, if you have exited, you are not able to claim at the moment, at least.
Cool. Yeah. That's a stake. Cool.
So if you want to rage quit, you need to, if you want to quit, you need to be sure to claim your rewards before you quit.
Do you wanna get into the code, just to walk through a little bit about the payout pool, especially with this SLA, sub SLAs, etc. So,
can someone else go over the code?
Yeah, Phil.
Phil, yeah.
Hello, can you hear me? Just for this.
Mm-hmm.
Yep.
Okay, let me share my screen. So can you see my screen?
Yeah.
For the peer pool? Yeah. So as we discussed, we have, a bunch of contracts like the proposal registry where the proposals can register with their peer public keys and their signatures. And also we have the reporter registry where, reporter showing and, submit reports for the slashing amount, something like that. And we have the peer pool contract, which will handle the real distribution for the SLA registration and distribution reals over the proposers who join the SLA. And also we have service provider logic. So we have the service provider factory contract, which will create, bunch of, service providers if they want. So as we discussed, they need to provide the real token amount and duration, these kind of params for the service provider, configurations. So let me start from the proposal registry first. So as I mentioned, this smart contract is to allow proposals to register, and they need to be activated in this proposal registry to join any SLA pools of the peer pool. So this is a scenario. So they call the register proposal function. They need to provide the peer's public key and also some signatures, and also they need to submit the active balance. And also we do some verifications and register proposal. And at the first time, the status will be registered. And after some period, the proposals can be activated by this activate proposal function. And finally, the proposal status became active. Yeah. And then the proposal status became active. They can join any SLA pools in the peer pool. So they can join the SLA pool by specifying the SLA pool ID and his peer's public key. So we do some global check here. If the proposer, the proposer public key is active in the proposal registry, and also if the message sender is the correct representative of the peer's public key. And that's it on the proposal registry side. The proposers can join SLA pools and start, getting some distributions of the real tokens. Yeah. And also, let me talk about the SLA registration side. So we have the service provider factory, which will create a SLA pool on the peer pool side. So there is a create function. And when they create an SLA, they will create a service provider instance and provide, service provider instance and real token to the peer pool. They call the add pool function. So let's see the add pool function. So the first one is authorizer, which is the service provider instance in this case. And also they need to specify a real token at the initial state. And the pool is registered on the peer pool. So we have the pool index, which is increased when a new SLA joins. And and the pool there is a pool authorizer logic, which will be the service provider instance. We have some hook functions defined like the join and exit. So this join and exit function is called in from the peer pool when a user tries to join. So user can join the SLA pool, and when they join, we check if the pool has the service provider instance. If it has the service provider instance, we call the hook functions of the service provider to verify if the peer's public key can join the SLA or not. So let's say we have some conditions, which we check some conditions for the peer's public keys here. So let's say one is the first one is that we check the peer's public keys counts they joined to the SLA. So let's say we defined 100 peerless public keys limit, then only 100 peerless public keys can join the S3. Yeah, we don't accept any other peerless public keys joining the S3. And also we define some minimum active balance and check if the peerless public key has enough active balance to join the S3 pool.
So Phil, that means like, so if I am a node runner and I'm running like 100 keys, I don't have to. I can decide which validators are working for which pools, right? So I can have 20 keys, working for SLA1, and I don't have to like commit all the capacity to each SLA, right? I can decide at the PLS key level.
Yeah. You can split 5 keys to SLA1 and 5 keys to SLA2 if you want. Yeah. It's on the peerless public key level.
So then how am I claiming my rewards?
Yeah, so also there is a claim function. So as we discussed before, there is 2 kind of claim functions. So one is for proposers. So proposers can get the real tokens and claim their reals. And we have some check here. So we mentioned about the cycle amount before, right? The global cycle amount and we have the user cycle amount. This cycle amount should be reported before the claim. Yeah, until the previous cycle amount should be reported to claim the real tokens. And also, I think I need to mention about the reporter registry. So reporters can join the reporter registry. Register reporter, and and once they register in the reporter registry, they can submit reports. For example, some slashing, the proposer slashing. For example, so in this case, they call the process proposer slashing function of the PR pool, and when this function is called on the PR pool side, so the report has the real token and amounts, and this amount should be slashed from the proposer, and half of them are distributed to the reporter, and half of them are distributed to the other SLA, other proposers who join this SLA. Yeah. And let's say if the proposer doesn't have enough, real token to pay the debt, then we just increase the debt amount of the proposer, or for the pair pool and for the reporter, and this debt will be paid out as the proposer get the reals on for the distribution schedule, right? So yeah, this is the debt measure of the proposer side, and also there is another claim function for the reporters. So yeah, reporters can claim the real tokens from the SLA pool. So this reporter reals is coming from the submit report slash amount, and half of them are distributed to the reporter side. Yeah, we have two kind of claim functions.
So how does the validator registry, actually, the proposal registration works? There are two kind of validators, right? You have Stakehouse validators, you're approving the slow tokens, and then you have and all the other validators get the ETH, but then slow tokens actually will not, when it gets slashed, it gets forfeited, but it's not going, the person can just top up and get it back. So what's the difference between these two?
Yeah. So when a proposer trying to register in the proposer registry,
Mm-hmm.
we check if the PLS public key is a part of Stakehouse protocol.
Right.
If it is a the PLS public key is a part of Stakehouse, we check if the PLS public key is active, and also we check the slash amount for the slots, and we check if the representative, the proposal representative is the collateralized owner.
So for clarity, the Stakehouse protocol has a smart contract that can actually give you, this is the BLS key is part of the Stakehouse universe. It could be part of LSTs, it could be part of any other applications, it could be part of anything, but it will be kept in the Stakehouse registry, right? So you just reconcile that, and then you get the collateralized slot token balance, active balance, right?
Exactly.
Is that 4? Is it 3? Whatever it is.
Yeah, and also if the PLS public key is not a part of Stakehouse, then the proposer needs to pay some keys as a collateral. So there is a variable that specifies minimum keys amount for registration that can be updated by the proposer registry owner. Maybe, that can be updated, and then we get the keys from the proposer side to this proposer registry. This amount will be.
Do you mind explaining what is KETH? Like what is this KETH?
So keys is a kind of tokenized, ERC20 token. So which holds the SDs and RS and DEs, those kind of LSD tokens, and manage the liquid stacking yields to DE side. So we increase the DEs balance of the votes so that to increase the APR of the votes.
So the KETH is accepted here just to make sure that all the other LST tokens like STETH, RETH, and CBETH can be included, because they can get KETH just simply depositing their STETH or RETH or CBETH or any other LST tokens that get listed for the KETH vault. So essentially, it will allow user just to deposit those tokens, and it automatically mint the KETH. The KETH will basically manage all the risk of this LSTs, like the depegging, whatever it is, but make sure the KETH is the underlying nature of the KETH is you can redeem KETH for ETH, right? That's so it's basically ETH with a fixed yield, but it's backed by this liquid staking tokens. So if a user, a validator who is having STETH or RETH or CBETH or any other LSTs, they can simply deposit that, and they will basically get this KETH. We show that if there is a lending contract that can also accept all these tokens and just wire it through the KETH, and then the KETH will be the one that is taking. So rather than going through all kind of direction, it's just taking this kind of one unified KETH as a collateral, but the KETH will accommodate all LST tokens out there, correct?
Yeah, correct. Yeah.
Thank you. Okay. So what happens when it gets slashed?
Yeah, so when the purposes get slashed, so this function from the reporter registry side. So the reporter reported this proposal should be slashed, then they specify the slash amount, and in this case, we take the slash amount from his case collateral, decrease his proposer's case collateral amounts, and transfer it to recipient address. Yeah, that's the logic.
What happens if the slot gets slashed?
Yeah, so in this case, we need to interact with the Stakehouse registry contract. Yeah, but it's currently not implemented.
Right. So if the slot is getting slashed, it get forfeited, and then up until the slot get topped up to release, the payout pool can receive all the MU rewards from the syndicate contract, right? That's been it receiving.
Okay. Yeah.
Cool. Right. Anything else, guys? Just you want to ask in this code? Anyone have any questions? Cool. Thanks, Phil. So, couple of questions, if I may. So now this, normally we have this kind of the consensus-less stake. If it doesn't really need any withdrawal credentials need to be attached to our contracts, right? Nothing is there. There's no such notion exist. So hence all the slashing is immediate. It's atomic. It's just like, it's pretty, the middlewares can get the slashed, but there's also this earning slashing because you're qualified as a validator in the consensus layer. If you're not performing there, you will not get the earnings, right? Because that's how you've been selected in the first place. But then if you in any kind of misbehavior, then you basically get slash your ETH, and that actually get dispensed immediately. So which Vitalik was writing, I think he wrote a couple of weeks ago about this overloading consensus. That isn't really applicable here because there's no margin call. There's no withdrawal credentials. It will never get accumulated. In a standard way to looking at it is if you have slashable ETH, and if it is just basically you can only withdraw on the exit of the validator, which basically saying that you should exit the validator tomorrow. That's not the case here. It's just very adaptive. You can get slashed, but you can top up. You can just keep it going on the execution layer. On the time of exit, it's your validator, it's your money, but the in between, you can reuse it for as many middlewares, and they get slashed. They get the security. If you misbehave, you get slashed, but that's also get rectified immediately.
So is there a scoring system for if I have a node, can I just join 10,000 SLAs, or is there does it depend on how much collateral I put in the system?
So there is a cloud fee structure, how the utilization ratio calculate how much. So you have this kind of a total stake and how much slashable at the one epoch. Maybe Subhashish can explain this better. How do you basically slash? And there is a formula. That formula calculates each slashing slab. So if you over the threshold of the slashing, correlated slashing, you will get ejected from the network immediately. So that's very much aligned with how the Ethereum works, right? You have this kind of correlated penalty because you don't get slashed 32 at one slashing event, unless that you are taking down the network or something in Ethereum. Similarly, you get this kind of a minor slashing comes, but you get this kind of credits. That's how the cloud fee slashing works. Maybe Subhashish, you there?
Yeah, I was saying that only there
you want to just quickly give some view of this kind of how the slashing, because this is automated, right? Because a validator can join as many SLAs they want, but then how do you know that if they have too many SLAs and if they're getting slashing, when should the contractor take an action immediately?
Yeah, right. So the thing is, we allow for as many SLAs the validator wants to join, we allow them. It's just that we it should have a minimum balance that is set as a part of SLA only. We have a fixed formula that is again part of SLA that determines how much slashing each slot would result in. Each slashing, how much amount will reduce. So after every slashing, we make sure that there is enough balance, enough money for one more slashing. So that translates into the fact that let's say we get slashed, we have, let's say, 1 ETH left. The another slashing event on another SLA with another formula, we know that because of the initial deposit, one slashing for a slot will result in 1.5 ETH being reduced. So that's technically not possible. So we just remove the validator at that point. So that's what we do. Basically, we allow for as many SLAs the validator wants for, but we make sure that there is always money for one more penalty. And if that's not the case, we just remove it.
So the removal is a reporter derived action, right? When you say remove, just report it, and it will kick the validator from the payout pool.
Yeah, the reporter will basically tell it because the condition for slashing is given by the reporter itself.
Right, right. So when the SLA gets registered, that predefined category will actually feed the system how the slashing quotients is being governed, right? So I want to have like security from 28 in active balance to 32. Then you don't really need that kind of slashing much higher, right?
Yeah, right.
All right, cool, cool. Anything else? Any other question, guys? Keep asking. All right, I think we have, yeah. Cool. Thank you. Thank you, everyone. Just we'll just keep updating another one day. Excited this one to come into testnet. Bye.